so other than the neuron, we're going to have glia cells. Okay, so neuroglia is the full name, because get it? Neuro for nervous tissue. Glia is the other part of the name. But a lot of times people just abbreviate and call them glial cells, because we all know the only place they have glial cells is in the nervous tissue, right? So we can drop the neural part. All right, so here they are in bold print. Okay. Oligo, micro, astrocyte, and ependymal cells. Now notice, where are we? You guys recognize this picture? The brain. So are we CNS or PNS? CNS. Okay, so I'm going to list them here. We have neuroglia, which are oligo, dendrocyte. We have microglia. We have astrocytes. And we have ependymal cells. So these are glia. Okay? So, even without looking at the description, the text, you just go off of the picture. Okay, let's just go off the pictures. What do these oligodendrocytes seem to be doing? Just looking at the picture. Okay, so I'm just writing these names down, guys. I mean, you don't have to like read my scribble, but here it is for you, right? I just wrote these guys down because that's what they are. They're glial cells in the CNS. You told me, right? All right, so let's look at the picture. Anyone? What are these oligo doing? They're forming connection with what? The myelin sheath. They form this whitish myelin sheath around where? Around axon. Okay. Remember the picture before the break? I showed you a neuron, and we had myelin around axon as well. Agree? So, a trend, don't you think? Myelin around axon. Okay? And that's what it is. The oligodendrocytes, they, one cell, can connect multiple axons. Agree? And give these myelination, we call it myelination. So one oligodendrocyte can myelinate multiple axons. And that's what we call white matter. I've introduced gray matter before, right? Now I'm going to introduce white matter. Oligodendrocytes will respond for white matter. So let's make a connection here. True or false? White matter will only be axons. True or false? White matter will only be axons. True or false? Answer is true. Gray matter should only be what? Fill in the blank. Dendrites and cell bodies. Okay, so now you understand when I say white matter or gray matter, or when you read white matter or gray matter, that's what we mean. Okay? Alright. Let's move on. And by the way, why this whole thing about hoopla about myelination? To speed up nerve conduction. And you'll learn about why next semester, but for now, just accept the fact that myelination will speed up nerve conduction. Okay? The mechanism will come next week. Come next semester. All right, let's move on. Microglia. Microglia. That's the cartoon up there. What does the word micro mean? Small. Does that look small to you? Yeah, they're tiny compared to the neuron, right? This big old thing is a neuron. Agree? Tiny. And so I kind of remember their name to help me remember what they do. Microglia, I think microorganism. What's microorganism? Small organism, right? Give an example of microorganism. Anyone taking microbiology? Oh, that's
Lactobacillus.
yeah, bacteria, virus, right. So these are things that could kill you, yes? Could cause infection, yes? So microglia deals with microorganism because it cleans, it keeps the brain clean, protects the brain from invasion. You see the connection? That's an association, right? Right, so example of how to try to sort and figure all this out is try to use association, otherwise just too much information to know. So microglia, associate to microorganism, associate that to protect the brain from getting infection, okay? All right, astrocyte. Okay. I'm gonna stop talking here, I'm gonna have you talk to your neighbor. What do you think is going on? What's going on here? Talk to your neighbor. Figure out the job of an astrocyte.
Oh. If an extra. Looking at it in the going back to what she said about the green matter, she just said dendrite and cell body, and the white matter is the next one. Yeah.
Okay. Come up with something. Okay, Catherine, what do you think? Kathy, sorry, Kathy. Give me astrocyte. What does your group come up with? What's the job of astrocyte? Okay, yeah. It connects the neuron to capillary. Yes? What's in a capillary? You should know this by now. Anyone? What's in a capillary? Blood. But in that blood, what kind of stuff do we have in the blood? Water, oxygen, nutrient, agree? Okay. So in other words, the astrocyte is your blood-brain barrier. Blood-brain barrier. Is that very logical? Okay, just look at the picture. Blood, brain, barrier. Okay? Now, what do you think? Do you think the brain is pretty flexible and allows anything and everything to come through the brain, through the blood, into the brain? Or you want the brain to be very exclusive? Very exclusive. Agree? Okay. All right. With your fingers, no more than 5. How many different kinds of capillaries do we have in the body? We have 3. Okay, let's round them off. What are they? Fenestrated, sinusoid, continuous. Where do we see fenestrated capillaries?
In the spleen.
No. Fenestrated capillaries. In the kidney. What is that called specifically? Those capillaries in the kidney that are fenestrated. Glomerulus. Just last week, isn't it? Glomerulus. Good. Where do we have sinusoids? Now you can say it. In the spleen. In the spleen. Okay. What does sinusoid capillary mean? Hole. Hole. What kind of hole? Good. Big hole. How big? Big enough for blood cells to come through. Agree? And that's why they're sitting in the spleen. Make sense? All right. So, what kind of capillary would you want this to be? Continuous. Because you don't want any holes, do you? brain, you're gonna have continuous capillary, okay? All right. Whew. Almost there. One last one to go. Ependymol cell, people. Ependymol cells. The picture is not very good, so I'll give you some hints. EPE, what is that beginning remind you of? Epithelial, very good. Epithelial, right? What the heck is epithelial? It's a type of tissue. Keep going. It's lining something. Ah, is this lining something? Yeah, very good. So that's how I remember it. EPE, epithelial. It's a lining. It's a liner. It's lining a space in the brain called ventricle. Okay, it's lining space in the brain called ventricle. Okay. And anyone know what's in ventricles? This next chapter.
Muscles.
No. Fluid. Okay, so there are fluid in here. And so the ventricle in the brain has fluid, and the ependymol cell is going to help to make that fluid. We'll talk about that in a little while. Okay, so ependymol. Make sense? All right, any questions here before I move on? So you can read all this on your own. I'm going to skip. Now, unlike neurons, glial cells are capable of mitosis. Okay, they're smaller, capable of mitosis. What does that mean?
They can divide.
They can divide. Neurons, majority of the time, we know they do not divide, agree? Okay, once you have a fixed number, once they die, that's it.
They're dead.
Okay? So that's how they're different. And they're by outnumber the neurons by far. Okay, so there's a lot more neuroglial cells than there are neurons. And they're there to help. Okay, they help to help the neurons. Okay, now, so we went through all this, right? CNS glial cells, agree? Here they are. One last look before I move on. Okay. Now, I'm changing gear to this column, agree? So what should I write in this column? Satellite cells and so outside the brain and spinal cord, we also have glial cells. And let me just tell you, neurolemocyte. Aha, let's look at the picture. What do they do? According to the picture. What do you guys think? What do they do? What's this yellow thing? Axon. So what's happening around the axon? Myelin, right? Myelin. And now, how is, so that's the nucleus, okay? That's the little nucleus, little nucleus, little nucleus, little nucleus. How is the neurolemocyte different than the oligodendrocyte? There are multiple, what, keep going? Multiple neurolemocyte around one axon. Let me show you the other picture. Oops. Whereas an oligodendrocyte, how is it different? Multiple axons for one oligo. See the difference? Okay? They're both doing myelination around the axon, yes? And the yellow thing is an axon. What's an axon? Oh, come on, it was just last hour.
The tail end of a neuron, that where the signal travels down from.
Okay, so it's the end of a neuron where nerve conduction travel down with one axon, right? And why do we want myelination? To speed up nerve conduction. Okay. So in the CNS we have oligo, one oligo, many axon. Whereas in the CNS, whereas in the peripheral nervous system we have neurolemmocytes, and it's the opposite. One axon, but many neurolemmocytes. Okay? Do the same thing. They do this wrapping around the axon to speed up nerve conduction. So we call that myelin or myelin sheath. This whole thing's a myelin sheath. They're myelin. What color does it look? White. So that's why in the brain we call it white matter. Because it looks white. Now, another name for neurolemmocyte, that's kind of a mouthful, isn't it? What's another name? Schwann. So I will use both because the textbook uses both. Okay, so Schwann cell is the nickname for neurolemmocyte, okay? All right, now you see the in between, there's the neuron here, right? That's a lab question, right? Lab, neuron here. Okay, now let's go to the other glial cells. We have satellite cell. What do they do? Someone just tell me, what does it look like they're doing? Right. They're protecting the cell body. Of what? Neurons, right? Cell body of neurons. And in this picture, it's showing what kind of neuron? A sensory neuron. Right? Sensory neuron. Unipolar, multipolar, bipolar. What do you guys think? Unipolar. Okay, so sensory neurons, unipolar. And they, in addition to, what are these white things here? Like marshmallow. What are these white things? Right, neurolemmocytes. They also have satellite cells. Okay, they all have satellite cells. And they're hovering over the cell body to protect the cell body. Okay? All right. A lot smaller than a neuron, agree? Because there are multiple around the cell body. Okay? And they're found in this bump, which is a ganglion. What's a ganglion? Cluster of cell body in the CNS. Is it all fit together here? Yeah? Yes.
So I'm just confused. The neurolemmocyte, is that like the white myelin sheaths are neurolemmocytes?
Yes.
Okay.
The neurolemmocyte makes the myelin sheath in peripheral nervous system. Okay. All right. So here's a good picture.
Because what it's pointing to, it's like blank.
That's what
So here's what's happening. So this cell here is a neurolemmocyte, okay? And that's an axon. So the cell body is like up there somewhere. Does that make sense? And so what's going on? What's happening to this neurolemmocyte?
Wrapping around.
It's wrapping around the axon, agree? So keep going with this picture and look at what's happening. You have multiple layers of this neurolemmocyte around the axon, and that's myelin sheath. That's all it is. Myelin sheath, and there's multiple layer around an axon. And it's all one cell. It's all a neural level site. But you know, the neural level site will end, right? And so there's gonna be a gap between each cells, and that's gonna be called what? The gap is the node of Ranvier. The node of Ranvier. So here we go. So what's this picture all about? What's this picture all about? What's on top? The oligodendrocytes, right? What's on the bottom? Neural level sites. Where are we? Brain or spinal cord, agree? Where are we here? Peripheral nervous system. We're comparing the two together.
So could you use Schwann cells and myelin sheaths synonymously? Like
Only in peripheral.
okay.
So these are called Schwann cells. You don't call that Schwann cells. Okay. But you can use myelin sheath anywhere, central or peripheral, right? They're myelin sheath. What causes the myelin sheath? That's going to be different.
Okay.
Okay? Does that make sense? You guys understand? Okay, so myelin sheath could be anywhere. Myelination, anywhere. But oligodendrocytes are only found in the CNS. Okay? All right. Let's move on. So continuing on the same deal here, we're going to look at, I know it's a little confusing, but I want you to pay attention to the details. Do you see myelin sheath around these axons, yes or no? Okay, remember, what's the definition of myelin sheath? Wrapping, right? Do you see that around here? No. So even though there's a neural lemma site, this is not myelinated. Okay, this is not myelinated. Okay. So we call it unmyelinated. Get it? Unmyelinated, not myelinated. So not all axons are myelinated. Okay. So here's an interesting picture. What's going on? Talk to your neighbor. Talk to your neighbor. Wake you up.
I'm still confused.
I think it's like how you get like a fracture and then you cut the nerve. Yeah.
Could be.
It's how the axon will, if the axon gets cut off, it's gonna rot away. So it's like a
And then it starts, oh, and then the neural site.
that's not it. You
Regenerates?
have tendinitis.
Okay, so the neural site really is just that like body. So that's like one, two of them, two separate ones, right? It's not like this cell making one. That's a separate cell.
It's getting severed
And then all of
because it
it,
gets cut.
it actually
The rest of the
looks
axon starts to
Hey, I need
degenerate.
a volunteer.
looks like a big piece.
Okay, go ahead, Nathan.
It's where the axon is cut, and then it's showing how when the axon's cut, it will degenerate from the synaptic end.
Okay, so axon is cut, okay, agree? Are we in the CNS or PNS? Peripheral or central? Peripheral. How do I know it's peripheral? Neural level site, good. So it's peripheral, agree? Do we often have injury in our peripheral nervous system? Yes, so this happens all the time. Can we regenerate? Can the axon regenerate? sure? Look at this line. Regeneration 2. Why would they call it regeneration 2? Because it may regenerate, right? So, regeneration 2 formed by whom? By neurolemmocyte. So yeah, the part that got cut distally, which is downstream from there, is going to die. But this part is still alive. Where's the cell body? Over there, right? Is the cell body intact? You think it can survive? And it's going to grow. It's going to grow if the neurolemmocyte provide that regeneration 2. So here's the ending. Ta-da! Does it regrow? Yeah. So peripheral nervous system, there's a chance of regrowth and the chance of recovering the function. So you know how sometimes people have an injury and then they undergo physical therapy and recovery time? Do they regain some of their function?
Yeah.
This explains why. Does that make sense? Okay. So peripheral nervous system, we might be able to come back. Now, is this the same thing as saying mitosis? Does this neuron undergo mitosis? No. I'm not saying it's undergoing mitosis, but I'm saying it may regenerate the axon, right? It might grow a little bit. See the difference? We're not getting brand new neurons, are we? It's the same one, but it's growing back. Okay? Okay. All right. So it can't regenerate. All right, let's talk about a nerve. A nerve, okay? Where do we have nerves? Peripheral, okay? Peripheral, only peripheral. Okay, so what is a nerve? Here we go. Well, actually, before I go there. A nerve is a bundle of axon. Okay, nerve is a bundle of axon. And I need you to know that there are layers around the nerve. How many layers? Show me with your fingers. Good. 3. What's the outermost layer called? Epineurium. And then the innermost layer is endoneurium. Does this word make sense? Good. And then the middle layer is peri. All right, so here's a picture. Outer layer is what? Epi. And then you see these bundles, agree? Of axon. And then you have blood vessels inside to keep them all alive and happy, right? So around each bundle we have perineurium, and then around each individual axon you have endoneurium. Okay. These are connective tissue. You guys know connective tissue? Okay. So these are not nervous tissue. The endo, epi, perineurium, connective tissue. Okay, connective tissue. And then where do we have the myelin sheath? Deep to endoneurium, right? Aha. Do I like the kind of question where I ask you to go superficial to deep? Yeah. Could that be happening on this test? Yeah, probably. And this picture is worth 1,000 words, right? Okay? All right. Here's the histology. So nerves are always peripheral. Some of them carry sensory. Sensory. We talked about that already, didn't we? So sensory is what? Coming in or coming out of the CNS? In. So, which means peripheral nerve, some of them will be carrying motor, which is going out. Okay? All right. So I need you to understand. Go back to this picture. You saw that some nerves are motor, some nerves are sensory, agree? And we do have nerves that are mixed, meaning both motor and sensory. Now, You only see the axon, agree? Where are the cell bodies? Up there or down here? Or both? Alright, let's just take a look. Cell body. Up there, that's number 1. Down here, number 2, or both, number 3. Up 1, down 2, both is 3. A little bit of a thinking question here. I kind of gave you the hint. Nerve can be motor, sensory, or mixed. The answer would be both, right? Because a nerve can be motor, sensory, or mixed. If it's mixed, then the axon that you see, the cell body might be up there. The axon is coming down, agree? If it's the opposite, if the cell body is down here, the axon is carrying the message up. Does that make sense? And so, neurons. Let's talk about neuron versus nerves. Nerves versus neurons. What do we say about the direction of flow in a neuron? Is it one direction or bidirectional? One. Agree? And let's go through this again. We start with what on a neuron? We start with dendrite to cell body to axon. Always that direction, agree? But in a nerve, it could be bidirectional. Nerve can be bidirectional because the axon is all you have. You don't know where the cell bodies are. Does that make sense? Cell body could be up there or down here, in which case you have two direction flow. See the difference? Nerve can be bidirectional, but a neuron is only unidirectional. Okay? Make sense? Okay. Okay. So wrapping it up here, I want you to understand synapse. That is how one neuron meets up with the next neuron. Okay, that's a synapse. Okay. Synapse is where one neuron meets up with the next neuron. So here's the picture. Okay, right here. The first neuron, the second neuron. Okay? What do we call the first neuron? Presynaptic. Like that word? Pre? What does pre mean? Before. What about this neuron? This is the post. What does post mean? After. Does that make sense? So right here, where they meet up, that's a synapse, okay? Easy? Notice we have axon, teledendria, right? Axon, synaptic knob, and then it meets up with the next neuron. Does it have to meet up at the dendrite? Does it have to meet up at the dendrite of the postsynaptic neuron? Yes or no? Look at this picture. Must the presynaptic neuron synapse with the postsynaptic neuron at the dendrites? No. Because right here it's meeting up at the cell body, right? Okay. Okay. So to simplify this picture, they draw this, because it's faster to draw. So what's this round block? Cell body. What's this long line? Axon. And that is how we draw synapse, okay? It's just an abbreviation. Make sense? Alright. Alright, so let's look at this picture. What's going on? Go ahead and talk to your neighbor. Ask your neighbor what's going on in this picture.
What's up? Did you just make it closer to me?